So welcome to a discussion of climate change in history. I've got one master PowerPoint and it goes to a series of other PowerPoints, and then near the end, I'll show you the URL where you can download these all if you want them. So we're going to talk about this climate map in a few minutes. But first, just about a minute and a half about how we know what we know, because I know that I wrote that in the abstract, and you probably should do something close to what you said you're going to do in the abstract. So no one was alive a long time ago to record what the temperature was like. Basically means that we have to deal with something called proxies, and that's just indirect evidence. Now, here are a handful of useful climate proxies. And I'm not expecting anybody to memorize. There's not going to be a quiz on this list or anything like that. I'm just going to point out that I have personally done about 5 3/4 of them. In other words, I've been out on a frozen lake and I pulled the core up and we've taken a look at it and counted the varves in it and took a look at the pollen that was there to try to find what was growing in that particular place a long time ago. I've taken and analyzed more than a couple hundred tree ring cores. I've crawled into cracks in a petrified sand dune in order to dig out a pack rat midden and see what seeds that rat had stored in there. I helped a colleague track plant invasions by noting the phytoliths that are in hundreds of soils from Texas to Manitoba. I've used radiocarbon dates to date the ages of soil layers buried by ancient river floods. I have crawled into caves to help measure stalactites, but I don't count that because I didn't do the chemical analysis. And I've watched people analyze gas bubbles in very old ice. All I'm saying is, if you've got questions at the end, I do have some firsthand experience with some of the ways that we know what things were like a long time ago. And that's a base for analyzing the evidence about links between climate and history. So with that, we are going to go look at some GIANTS PowerPoints. They are on the GIANTS site, which is at the Ottawa ISD. The PowerPoints are not designed as lectures. They're designed as guides for students doing hands-on activities. And I don't know how many of you might have been able to download these things. They're actually on the bottom of this session. Wave your hand if you did download them. Now, it doesn't matter because I'm going to show them anyway. But you could have downloaded them and you could be marking as we go along. Bear in mind that this is all about guiding a student to finish a map on their own in front of them. So with that, I will look at a general PowerPoint about climate and history, and then the 3 items that were mentioned in the abstract about the Norse, about the steppe nomads, and about the Ming Dynasty in China. And maybe we'll make a little detour into Texas because it seems to be in the news these days. So with that, here are the URLs for these things. It's just ssoaisd.org. And with that, I'm off to something called Climate and History, or the real title, The Movable Desert Maker. Now, this thing has gotten changed a little bit. So I noticed that a couple of people here have probably seen an earlier version of it, but there's been a bunch of new research within the last 5 years about the movement of this Hadley cell. So the basic notion is simple. To understand the role of climate in history, you have to be aware of 3 things, and they operate at different scales, both spatially and temporally. You need to know something about the system that makes tropical deserts, something about the systems, plural, that cause natural climate cycles, and the basic difference between weather and climate, especially if you happen to live in Texas these days. A typical climate map has an enormous amount of information on it. And if you give me a beer sometime later, we could go into the research that backs it up. But the simple fact is, a student cannot remember this map. You can't tell them to study it and expect that they will remember it at all accurately. They have to do something on the map, and what they do has to be much, much simpler. So let's do something simple. Let's describe the pattern of the climates that have less than half the amount of rain that trees need. In other words, the dry climates of the world. And if you say that, and by the way, we provide a master so that you could print this map and the students could be marking it while I'm talking about it. But first, we should look at what causes a tropical desert. And the answer is rain near the equator. In other words, the tropical desert is not caused by what's happening right there. It's caused by something that's happening closer to the equator. This is basically how it works. I've tipped this globe so that the equator is up, and sun-heated air rises and makes rain around the equator. Now, we've known this for, I don't know, 600 years, something like that. We also know that air goes up, has to come down someplace. And we've known about where it comes down, because where it comes down is driven by the basic facts about the Earth, how big it is, how fast it rotates, how far it's from the sun, and so on. The general rule is every rotating body in the universe that has a gaseous atmosphere will have a rising band at the equator, and it'll come down someplace. On the Earth, the air comes down roughly on the tropic lines. That's lucky, I guess, for us teaching it. And where it comes down, it makes a desert. But if the Earth were a little bit bigger, or if we had more carbon dioxide in the air, and we'll get to that in just a minute, you have to ask the students to put this in their own words. And this comes as a surprise to a lot of students, that the deserts actually start in the ocean about 1,000 miles west of each continent. In other words, you start out here, and that's where the desert begins, over the cold ocean currents that are out there. And then it spreads to about 20 degrees of latitude, roughly 700 miles north-south. And it goes across the continent until it runs into some mountains. So in South America, the mountains are right near the coast, and the desert is only about 20 miles wide. In Africa, it goes halfway across the continent in the Namibian desert until you hit the Drakensberg Mountains. In Australia, you go way, way across until you hit the eastern edge of it. So we have the Great Australian Desert dominating most of it. In addition to these tropical deserts, there are deserts up in the mid-latitudes. They're caused by the rain shadow. Westerly wind goes up over the mountains, and when it comes down, it makes a desert. There's one down here in South America. It's called Patagonia. There isn't one in Australia or Africa because they don't stretch far enough to get into the westerly region. So how does this relate to history, and especially to our GLICs? And again, you've got a master, the students can be writing on it. I tend to cut this in half and give them the one that doesn't have the writing on it at first. And we take a look at that graph. It's a simple graph of temperature over time, but it's a multi-proxy graph. In other words, this is tree rings and radiocarbon and cave sediments and all these other measurements kind of crystallized down into a very simple graph. Hunters thrive after the ice leaves the continents about 9,000 years ago. Agriculture starts about the time that the temperature started to turn back down a little bit, and hunting got harder. And by this time, people had killed off most of the big, dumb, slow animals. One of the facts, again, that comes as a surprise to kids is that farming is a lot harder than hunting and gathering. It's not like we went up to farming. It's like we started farming when we ran out of other easy sources of food. And the evidence is very clear. The hunters and gatherers were generally taller and a lot healthier than the early farmers were because they had a better diet and they didn't work as hard. And then we go on. The Central Asian nomads that we'll talk about later is about 4,500 BC. The Mesopotamian cities started around 3100 BC. South Asia did real well during a warm time, about 2500 BC. Turkey did well, and the islands in the Mediterranean during a cool time and a rainier time. Then when it got warm, the sea people arrived. It got cold, and the Greek area was a good place to grow a lot of food. Rome had to move northward. For the first couple hundred years, the granary for Rome was in North Africa. But when the temperature of the world got warmer, North Africa got drier, and Rome needed more food somewhere. That's why they sent Julius Caesar up into Gaul to go capture some farmland, and preferably capture some farmers as slaves to work the farmland. Temperature turned colder. Northern Europe became a less hospitable place, and the barbarians invaded Rome. If a Roman historian writes it, of course, it's those evil barbarians that won our freedoms or whatever. If the barbarians write the story, it's we're hungry and they've got food down there. When the temperature got warmer, around 1000, we had both the Vikings and the Mongols. The temperature turned colder, the Ming Dynasty collapsed, and we'll talk a little bit more about them later. Right now, and again, there's going to be a handout for kids, we can put these tropical deserts we can put these facts onto a map. Remember, the tropical desert form where air that rose at the equator is pushed back down. This downward air movement, it's called the subsidence, is going to be farther away from the equator if the Earth is warmer and the storms at the equator are stronger. Let me repeat that. Subsidence, the downward movement of air that makes deserts, is going to be farther away from the equator when warmer air makes storms stronger near the equator. Is that right? Now, the science for this is not what I would call easily accessible to normal beings. The math is a little bit hairy, but the equations make very specific predictions. They say if you have a ½ degree rise in temperature, the desert is likely to move somewhere between 50 and 150 miles further north. And there's a print activity up on the MCSS website and the Giants website that students can mark this as we're talking about it. So the question is, when the global average temperature is high and the desert is pushed a little further away from the equator, who's likely to be helped? And one person that's going to be helped a lot is going to be South Asia, and particularly the Indus River Valley, that's going to have more rain coming in those rivers there. Another one that's likely to be helped is in southern Mexico, Guatemala, in other words, the Mayan civilization areas. Third place that's likely to be helped is the areas in Peru over here. These are the Huari and the Nazca and the other pre-Inca civilizations that started about 2,000 years. These plots, by the way, were made about 2,000 years before the Incas. There is a group of places that would get wetter in Africa and therefore be better, but I put a question mark by that because wetter also means more mosquitoes, and that means more malaria, and that means maybe it's not better. And then finally, I put 3 question marks out here in China, because although they did get warmer and wetter, it also brought some humongous floods. So you've got a handful of places that were helped, plus some northern areas that got warmer and therefore would be better for farming. Who's likely to get hurt? And the answer is every place that's just 50 to 150 or 300 miles north of these deserts. And all of these areas have had serious droughts within the last 20 years. We know what's happening in California. You know, the Lake Mead is way down and so on. Patagonia had its worst drought on record in Chile. Cape Town calls itself a national disaster. Australia's had a decade-long drought that they think is likely to get worse. In other words, the way you explain all of these droughts in different parts of the world is with the same mechanism. You're pushing the desert farther away from the equator. And located just north of the huge Sahara and Arabian deserts, the whole Mediterranean region, from Spain over to Iran, is going to be hurt under these conditions of warming. Now, that shows up most dramatically in Syria, where water drought is related to it. In fact, there's a whole bunch of these articles that say this. And even back when we were in New York, we'd looked up the numbers. There were about 550,000 climate refugees in camps long before ISIS came along. But if you take a random sample of 550,000 people, you're likely to get 10 to 20,000 young men who are bored, angry because they've been pushed off their land, looking for something to do. That's an ideal place to recruit somebody into ISIS. And basically, that's the story. ISIS is a consequence of recent climate change. And what's interesting is, so was the collapse of the Akkadian Empire, Sargon and all those dudes way back then. And we'll get to looking at older history in a minute here. Let me do the other hand much quicker. When the global temperature is low, the desert maker slips a little bit toward the equator. Who's helped? All the people that were hurt when they moved away. Who's hurt? All the people that were helped when hurt when it moved. Yeah, okay. Plus some northern areas that got colder. That is the science behind the simple fact that climate changes have had a big impact on history. And the closer we look at things like the Akkadian Empire or the Sumerian Empire, we're beginning to see how these climate impacts hit that. So global warming is going to be bad for some places and good for others. That's a simple fact. Now, when I've done this before, almost always people say, but what about natural cycles? And then they say, what about recent events like this? So I've got 2 3-minute PowerPoints for you. I'm going to go for them fairly fast and then let you know where you can get them. But natural cycles of climate really depend upon the wobbles in the orbit. It starts with an important fact. The Earth's orbit is not a perfect circle. It's a wobbly tilt on a wobbly oval. And one consequences of that, well, you could find the details on a ton of websites, so I'm not going to go into them at all. All I'm going to say is solar energy has varied a lot over the last hundreds of thousands of years, from a low somewhere around 400 watts per meter squared to a high somewhere around 500. That's a huge difference. And it drives a lot of the climate systems here. A high point in solar radiation comes roughly once every 100,000 years. A high point in temperature comes roughly once every 100,000 years. A high point in carbon dioxide, this is coming out of the Antarctic ice cores, comes roughly once every 100,000 years. And if you put all 3 graphs together, the high points pretty well line up. In other words, solar energy, temperature, and carbon dioxide are obviously related. One conclusion is beyond doubt. Temperatures have been higher in the past than they are today. They were fairly significantly higher in the distant past. I've got the present average shown as a kind of a band here. And they were a little bit higher quite recently, about the time that the steppe nomads and South Asian civilizations were developing. But these graphs have a huge problem. Most recent measurements don't fit the scale. And if you adjust the graph, you can see that CO2 today is way, way out of the normal range. Now, you guys probably already knew this, but I told you this is going to be only 3 minutes long. The system today is way out of line with normal cycles. And the activity that we give the kids And there is a printed activity like that. The handout is available up on the website. This is like your heart rate or blood sugar stayed between 80 and 130 for 40 years. And then in the space of a couple of months, it goes up to 200. What are you going to ask your doctor? And I suggested that a reasonable person would want to know why this happened and whether it might have some bad effects. So the conclusion of this part, the orbit of the Earth is not a perfect circle. There is a complex natural cycle in the amount of incoming solar energy. The big problem is, based on where we are right now in the year 2021 in this natural cycle, the Earth ought to be getting colder right now, not warmer. It's reasonable to want to know why that's not happening. And that should end this one. Then people wanted to ask me about Texas, and the answer is, yeah, discussions of climate change always have this problem of salient current events. Texas was unusually cold in 2011. Kalamazoo had 10 feet of snow the first year I got here. China had a bad cold wave in 2016. 4 of 6 New York's 6 snowiest months came in the last 10 years. And now Texas has its coldest day since 2011. And it's true, Michigan was colder than normal in 2014. But if you look at the map of the whole world, we were really kind of unique. In other words, as a blogger asked at that time, not just a blogger, my congressman, can global warming be real if it's unusually cold in the US? And the answer in about 50 languages around the world is yes, yes, and yes, da. In 2015, there was a cold pool, but it formed above the North Atlantic. So let's connect some dots. It's not that hard. You just have to remember that the effect of one cause could be the cause of another effect. And remember, this is going to happen to the Vikings, it's going to happen to the Ming, it's going to happen to the Acadians. And again, there's a handout for kids to write this in as they do it. So storms are stronger near the equator because the Earth is warmer right now. Warm water gets pushed into the Western Pacific because the stronger ITZ storms make for stronger winds flowing from east to west because the Earth is warmer. The Philippines have stronger hurricanes because they form over that warmer water because the Earth is warmer. Tropical storms carry more heat northward. Even after they're no longer a hurricane, they're still carrying heat because the Earth is warmer. The Arctic Ocean has got less ice in it, which means less solar radiation gets reflected away, which means more gets absorbed because the Earth is warmer. And then when you add advection of heat in the form of hurricanes and local heat from Arctic ice, we have weaker circumpolar winds because the Earth is warmer. And when the winds around the poles are weaker, the north-south loops of the jet stream get bigger. And they go farther toward the equator, and cold air can move further that way because the Earth is warmer. And Texas winds up with a polar vortex. And Texas politicians say, this cold proves that global warming is a hoax. Now, I mentioned a little earlier that the science for moving deserts was a little hairy. But the math of jet stream dynamics is just absolutely gruesome. Now, you can't teach this to kids. We've got to go at it another way around. We can do it with maps. The global effects are fairly easy to see. 2016 had record high temperatures in hundreds of places around the world, but a small area in the North Atlantic was cold. That's where the loop happened to be at the time. 2017 didn't get a big loop because they didn't have big hurricanes in the Pacific at the time. 2018 had a big loop. North Atlantic was below normal. And in fact, Central Asia and Central North America were a little cooler than normal. 2019, we had a big patch of cold air over the northern plains. individual effects are fairly easy to see, but the system is huge and complex. And therefore, there is some uncertainty about it. The uncertainty, though, is not whether global warming can cause unusually cold air. And this will be important when we talk about what happens in China, because they would have unusually cold air and floods in the middle of a warming time. So let's go back over here, cancel out that one. We've mentioned that the global climate system is out of line with the natural cycles. We've looked at some of these global maps. We've asked this question. The big point is that global climate change is not just about temperature, it's about the movement of these deserts. It's possible to predict the places that could be hurt. And these are the places where climate change had the most impact in history. And if you want, I've got a whole bunch of these studies that I can send you, and you can follow the rabbit holes a little further and get the data. But located by the huge Sahara, the Mediterranean region turns out to be uniquely vulnerable to this. Now, I'm talking just about deserts. There's also hurricanes, tornadoes, cyclones, droughts, soil moisture, stream flow, blizzards, glacier melt, and so on. Lots of other effects. So, let's go take a look at the Vikings. What can we learn by trying to put the story of the Vikings into the context of these global changes in the location of the deserts, and therefore the westerly winds, and therefore the temperature bands, and so on? And there are masters up on the website that you can download that students can have as we go along with this. Now I'm not talking kind of teacher to teacher, but I'm translating it into teacher to sixth grader. And what do we need to talk about to sixth graders? Because you might say that the Norse people lived on a couple peninsulas there. They might not know what a peninsula is. So most of our PowerPoints will have a definition card or something like that on it, and it will define what it is. The geologic definition of a peninsula is a finger of land sticking out into a body of water. The historical definition of a peninsula is it's a place that's easy to defend against an army because they can only come in. It's like a bedroom with only one door. You know which way to aim your Glock. And we have the students make a list because they might not know where Jutland is, or they might not even know where Iberia is because they hadn't used that word. So we walk them around Europe and have them identify it. It's a kind of a painless way. It's better than just giving them a list of peninsulas and saying, go find where these things are. So Greece is a peninsula, and it was relatively easy to defend at a place called Thermopylae. Italy is a peninsula, and until Hannibal figured out how to go through one pass up there, it was relatively easy to defend. Iberia is a peninsula, and the Pyrenees Mountains help protect it from the evil people up there in France. Scandinavia is a peninsula. Jutland's a peninsula. Wales, Cornwall, Brittany, Normandy is a peninsula. Scotland's a peninsula. Kola Peninsula is where the Ruskies had their Soviet submarine base during World War II. So we walk the students around where these peninsulas are. What made this particular peninsula so important at that one time in history? And it suggests that there are really two reasons for it. One of them, of course, is going to be climate. But part of the story is the effect of inventions. And it's worth noting that transportation invention helped the rise of the Vikings, and a construction invention helped their demise. Another part of the story is the effect of climate change. And that's what we're talking about tonight. So you remember this map of global temperature. Starting about the year 800, the Earth became rather dramatically warmer. Here is a detailed record, a multi-proxy record. It's cave sediments, it's lake sediments, and it's tree rings. of what the temperatures were like in Denmark since about the time of Julius Caesar. And if you take a look at that, you say, yeah, what does that mean? Well, the average frost-free season in 800, the year 800 was 105 days. And you say, what does that mean? Well, it's a lot less than the average frost-free season in the year 1000 was 170 days long. But what does that mean? The frost-free season at Mount Pleasant at Central Michigan University is 140 days. And hopefully they will remember from fourth grade in Michigan that Mount Pleasant, Michigan is just about exactly at the northern edge of the Corn Belt. South of there, you can grow some corn. And north of there, you can try to grow some corn. And much north of there, you can't grow some corn. So what we're saying is that in the area of the Vikings, you got a crop failure, even with hardy crops like barley and rye, roughly 1 out of 3 years. And the people were responding to that. They were making babies on the assumption that they were going to lose 1 out of every 2 of them in the first couple of years of their life because they just ran out of food, or they had a miscarriage because the woman was starving. By the year 1000 CE, crop failure had become almost non-existent, and the population of the Viking area was just exploding. The Norse homeland became a whole lot more productive, and as their population increased, they found out that the peninsula of Denmark just wasn't very big, and the young Vikings had to go somewhere else to make a living. And at first they were making a living as traders, but you all know that the line between trader and raider in history is very thin. It's like, if you don't want to make a deal on my terms, then I'm going to give you a deal that you can't refuse. Their spread was aided by a big invention, the longship. And there's lots of websites that talk about this. The important thing about the longship is that it could float in 2 feet of water. A typical Roman ship at the time required about 12 feet of water. And it's partly why there are so few good ports in the Mediterranean. I mean, Tarsus was one where St. Paul grew up, and so on. The longship could travel on shallow rivers and lakes as well as deep oceans. And as a result, the Vikings spread up the shallow rivers and lakes, trading and raiding. By the year 1015, they'd gone as far as Spain, Rome, Moscow, Constantinople. A bunch of them were down in Central Asia. It's partly why they're Afghani people with blonde hair and blue eyes. Has something to do with the fact that the Vikings arrived there and, how should we say it, planted their seed into fertile ground. By that time, the people of Europe had begun to learn how to resist more effectively. And one invention that was particularly effective was a high-walled castle. And you can make maps of how rapidly castles built over here. Again, this PowerPoint is not supposed to be a lecture all by itself. It's supposed to be a tool to support your discussion about the Vikings. About 1200 CE, the climate started getting dramatically colder. It's the beginning of a period of time that's called the Little Ice Age. And the summary for this PowerPoint would be: the rise of the Vikings was warming climate, and the invention of the longship gave this particular group of people an enormous advantage at that exact moment in history. A cooling climate and the invention of high castles greatly reduced that advantage. Here's a couple particularly good websites that you can wander out to: WW Castles World and Research About Ships, and you can get information about the ships, or send a couple of your better students out to them. And with that, we will call that one ended and go take a look at the steppe nomads. Unless somebody drastically waves at me. Now, the steppe nomad story that could start with a handout about some words, or we can just show the vast steppes of Central Asia. This PowerPoint is a little bit longer because I don't know what the kids' prior knowledge is, and therefore I put things in here that you may or may not need. Most of them had an idea what the Vikings were all about, but the grasslands north of the Black and the Caspian Sea could be a problem for some kids because they might not know where the Black and the Caspian Sea are. The climate in this region is more or less exactly the same as it is in central Canada. A satellite image makes that even clearer. You can see the grasslands are kind of this pale green here, in between the dark green of the forest and the light of the desert. And like I say, you might just want to delete all of those frames out if your kids have already got some facility with reading satellite images. We do have a clickable map that shows where the grasslands are all by themselves. And you can see that the Eurasian grasslands are much bigger than they were in North America. And they also go east-west, which made it much easier for the Huns, the Xiongnu, the Mongols, and these steppe people to travel great distances east-west. Now the question is, why are we spending any time talking about these people in Eurasia, especially since there isn't exactly a glick about them? And the answer is because your glicks are wrong. They actually think that the earliest civilizations were in places like Mesopotamia. And the grassland civilizations were actually a little bit older. In fact, the grassland cities of 70,000 people were 300 years before Ur and any of the early cities in the Mesopotamian area, and long before the cities of the Nile Valley. And our language and a lot of important inventions came from this area. Now, I don't know if I'm telling you guys something new here or not. You can wave at me if not. But all of these languages came from this area. And the question for the kids is, how can this be? The chronology is, there are some people living in the forested valleys near the edges of the grasslands about 7,000 years ago, right about there. And they've actually got a burial mound right at that place that we'll look at a little bit later. They lived in wooden houses. They ate fish from the streams, seeds and fruits from trees, deer and horses that they hunted. There were 6 species of horses at the time. 5 of them were slow. They went extinct. For 1,000 years, their population grew. Hunting became a lot harder after they've killed off the big, slow animals. The people learned how to keep a species of horse as a domesticated animal, but not to ride. About 4,000 years ago, they were basically keeping them as sources of milk and meat when they were not successful in hunting. Population kept growing. Hunting and herding became still harder. The grass is starting to get overgrazed. And the people learned how to ride horses. And when they could ride horses, they could travel a whole lot farther out. They invented a whole bunch of things like ropes and bridles and bits and things like that. It allowed them to go farther away from the river valleys. All of this land became available for horse herding, and they became the source of horses for other civilizations in other parts of the world, like China, like Mesopotamia, like Europe. They began to sell horses to people in other regions, and then the climate turned cold. And a lot of these people just left. They moved south. The ones that moved completely south of the Black Sea became known as the Hittites a little bit later on, and they've done genetic analysis in order to prove that, in fact, the Hittites were the parts that came from northern Italy. Others moved far off to the east across the high mountains. They're called the Tacharians, and they lived as hunters, herders, traders, and then they mostly disappeared as a separate group of people. Some of them joined the Xiongnu, horse riding warriors who sometimes attacked into China. Some of them became the Mongols a little bit later on, horse riding warriors who attacked both China and Europe. Meanwhile, back in the steppe region, the climate got warmer again. The population started to grow again, and the people learned how to build wagons. With the wagons, they could go even farther because they could carry some supplies with them. And in fact, they became mobile horse herders. They could camp and stay away for weeks at a time. The population grew even more rapidly, and the steppe people started to spread in a number of different directions. That's a long story that we can tell very quickly and put on a map, and it's a map we give the students to finish, because some of the people out of this steppe land moved north and eventually northwest, and they eventually became German, Dutch, Danish, Swedish, Norwegian, so on. Some went west, they became the Celts, Scots, Irish, Welsh, Romans. Some went north, became Ukrainian, Russian, Polish. Some went southwest, later, became Greek, Serbian, Macedonian. Some went southeast, still later. They became Persian, Indic, and ultimately brought the Vedas to South Asia. In short, these people became known by many other names, from Ireland to Russia, Spain to India. And this is demonstrated by the affinities of the language and by the DNA, of which there's been a huge amount gathered just in the last 10 years. So let's stop for a minute and ask the question. If these people were so all-fired important, why didn't we read about them in the textbook when they listed the ancient river civilizations, or your Glicks listing the ancient civilizations of Egypt, Mesopotamia, the Indus Valley, and China? When in fact, the steppe civilization was 500 to 1,000 years earlier. There's three reasons why it's not part of the textbooks right now. Number one is this was part of the Soviet Union, and it was very hard for other archaeologists to study there. Number two, it is a contested part of the world. And just like Canaan, Israel, Palestine, doing archaeology there is risky because some of the people are doing it deliberately to prove that the Israelis were there first, and some are doing it deliberately to prove that the Palestinians were there first, and some of it, this is a contested area. It's a place with ongoing fights. And the third reason, probably even more important than the first two, is that the people lived in wooden wagons and they built houses out of wood. And you're just not going to leave much of an archaeological record. I mean, they didn't have the tools to carve big buildings and temples out of stone because they didn't even have stone in their environment. They were on a floodplain. They never tried to build a pyramid to last forever. What they left us are grave mounds called kurgans. Some of these kurgans get to be pretty big, but if you walked over there right now, you'd just think that's a natural hill until you actually dug a hole in it and found out that it was full of a whole bunch of old burial grounds, and those burial grounds were full of horses, weapons, pottery, jewelry, and all kinds of other things that the people buried with them. Now, this is a big part that you may or may not have to give to your students. We could use a map just to talk about the spread of horse-drawn chariots here. We need to show where the Black Sea and the Caspian Sea is, and that it's part of Russia, and that the area is actually bigger than the United States, and that the weather is more like Canada, and that there are some mountains, and between the mountains there's a big desert, and there's some forests up north, and there's a hardwood forest like Michigan off to the west, and the desert and the forest are kind of the edges of this big area called the grassland. And the people in the middle of the grassland invented chariots about a little bit before 2000 BCE. And the activity map that we give kids is that they say, this is where they had chariots about 2100 BC. And they're buried in these burial mounds, of which they've found thousands of them. And then after about 100 years, the idea of chariots had spread about this far. And then they could continue with the 3, 4s, and 5s. And when you're done, your map ought to look something like this. You take the numbers off and you get a typical spread of map. You notice that chariots got to Egypt and Mesopotamia and the Indus Valley about 500 years later. What does this map study tell us? Is that the people that started as hunters, hunting horses north of the Black Sea, were the inventors of war chariots. The idea spread very quickly. The Chinese symbol for war chariot is the same as the symbol that these people buried in their burial mounds 500 years earlier. And when you see a picture like this in Egypt, which is all about the big battle of Kadesh, where the Pharaoh fought the Hittites in 1274, you know 2 important backstory facts. You know, number one, that the Hittites used to live north of the grasslands, and that they brought the idea of the chariots with them. But both sides of the Battle of Kadesh were using something that up until about 20 years ago, we thought they had invented in Egypt and Mesopotamia. And they'd actually borrowed it from the steppe people. That's not the only thing they invented. Their language spread out with them. In ancient Indo-European, rota is how you say wheel, and ax is how you say axle. And we give the students a map that looks like this. In fact, there's a handout. I think I've got somewhere. No, maybe I didn't show it. Eventually, we called all these new languages, and it gives you a way to start talking about how languages spread earlier than when writing began, because these people did not develop writing. They just developed language. So for archaeological information, there's a great book. And for completely different line of DNA evidence, you can look at articles like this. This is all on the PowerPoint that you could get. So that's 2 stories. The 3rd story is kind of completely different, and we approach it kind of completely different than this curriculum. And again, you can download all this from the Giants website. So we could start by asking, why should America worry a little bit about China? You know, they've stolen our jobs. They're testing nuclear weapons. They became the #1 exporter. They're threatening ships all over the South China. They put a sophisticated satellite up in orbit. They built 3 times as many cars as any other country. They built 10 times as many solar collectors. They built a huge highway system in 1/7 the time it took us to do it. They built hospitals, power stations, ports, railroads, all over the Belt and Road. I'm going to suggest that some of that success has to do with the one-child policy, and some of it has to do with what happened 500 years ago during the Ming Dynasty. So, on the geohistogram, which if you haven't seen that diagram, you can go to the Michigan Geographic Alliance website. And you can get copies of it to give to your students. It gives you a way of showing where things are in space and time. Old is down at the bottom, new goes up toward the top, west is on that side, east is on that side. And you can point up here to the Ming Dynasty, and students will automatically encode that it was way east of us. And, well, actually, when you put some of the other things in, they would encode that it was just after the Mongols, and it was about the same time as the Reformation and Habsburg and the Songhai Empire. In other words, it's a tool that you can use. If your students are already using this tool because it's in the first couple lessons in the Giants curriculum, then you don't need these PowerPoints and you can get straight to the Ming story. The Ming are known for spectacular architecture. They're known for ceramics, silk, furniture, huge ships. There's Columbus's ship, and there's Admiral Zheng He's ship. Their trading networks went from China to Africa, Southern Europe. They rebuilt the Great Wall. They had a 1,000,000-man army. The army had rockets, gunpowder, cannons. The troops were very well trained. In fact, this picture is almost identical to the picture of Hans von Bülow training the troops at Valley Forge for the American Revolution as to how you have your front line shooting while your back line is loading. In other words, the same military tactics were invented over there. There's a question, and the question is, how could a culture that was this rich, this big, this sophisticated, this powerful, how could it possibly fall to a group like the, it shows on here, you know, how could they fall to the Manchus? How could they fall to a group that was less than 1/100th as big and didn't have these weapons? I mean, it would be like Guatemala defeating the United States right now. Guatemala having roughly the same population relative to the US that the Manchus had relative to the Ming Dynasty. If you go out to the first Wikipedia links, they talk all about the corrupt Ming government and that there was police brutality and rebellion and all that other kind of stuff. I humbly suggest that there might be another reason that might actually underlie all three of these things and be even more important. And the way we do this is to make it a reading activity for the 7th grade students. They've got a handout in the reading package that is basically what I just showed you with pictures about how long it lasted and how many people they had and what was the size of the army. There's also their location near the end of the Little Ice Age, where agriculture started about there and the irrigation in South Asia flourished and the Roman expanded into Europe and then the barbarians invaded back. It's when the Mongols spread across and then the time climate turned cold. That's when the Ming happened. But specifically, why did it happen in 1644? That's the next reading. And this is a take-home reading we give the students. And it's a story that's just made for middle school. It starts with how soldiers ended the battle by eating all the dead soldiers, because the Ming general actually gave an order to his students that when the battle was over, they were supposed to pick up all of the dead soldiers that still had some meat on their bones and eat them. It's a true story. It actually happened. And we can learn something from why it happened. Starts with the superpower of the world in the year 1600. Read the background. If they were so powerful, why did they collapse? In 1583, this climate started to get cold. Cold air tends to have high pressure, and that pushed the storm tracks further south of their normal position in Asia. That caused a major drought across China in 1584. Southern China had floods. 1587, floods damaged crops. 1590 was better, but droughts and floods returned in 1591. 1594, there were reports of people eating animal skins and bark of trees and actually digging up graves to see if there was anything to eat in them. By 1600, the largest volcano in South American history erupted. The explosion was huge, 10 times as powerful, and so on. The reading goes on. Then the activity, we give 6 sentences from the story about it, and the student is supposed to circle F if they think it's a statement of fact. I'm doing exactly what happened in the last session when they were talking about the difference between fact, explanation, and opinion. We just call it fact, theory, and opinion here, the name. But it is basically an ELA activity. So if you don't want that ELA activity, we actually had 6 ELA activities, and you can pick the one that fits your ELA curriculum at the time. One of them is all about truth or myth. And when it says lower annual temperature makes more floods in South China, is that something that's true? Or you might be true, or I don't know, or I'm pretty sure it's a myth. Or you could do a causal diagram. If the climate gets cold, it tends to make drought in China. If you got drought in China, locusts become a bigger problem. If you combine drought and locusts, it becomes a crop failure. If you've got a crop failure, you're likely to have a famine. In other words, students can build a causal model, or they can just read Confucius, because one of the things about the Ming era was a revival of Confucianism in China. And one of the things Confucians kept saying was the superior person, or however you want to translate that, when resting in safety, does not forget that danger can come. When in a state of security, does not forget the possibility of ruin. When all is orderly, he does not forget that disorder may come. And then you ask the question, what did the Ming do about it? Well, the Ming had all kinds of things, but at this point, I'm beyond my climate story, and I'm going to stop this PowerPoint, even though it does go along to talk about the granaries that the Ming had built. They actually survived 5 extremely bad years by tapping into the things that they had. The problem is they got 7 of them in a row. And in that 7th year, people were starving everywhere and people were rebelling everywhere. And the Ming tried to crush the rebellion by sending troops out. And the result was that one of the disgruntled people went and opened the Great Wall and let the Manchus in. And you know, the Great Wall never worked as a wall. Now, what might be relevant to today? Well, China has had problems of losing more than half their population, at least 4 times. And each one of them was the collapse of a dynasty. And each one of them is keyed to one of these climate events. You'll hear this again and again and again from me. Climate change is bad for some countries, good for others. It tended to be bad for China and good for the Xiongnu, the Mongols, the Manchus. And a culture that learns how to save is well positioned. And coming out of the Ming era, China had a very powerful ethic of savings. Right now, they save and invest about 46% of their income in new factories, new roads, new ships, and so on. By contrast, we invest about 17%, and most of that goes to repair, to maintenance of stuff that we've got. And we can go into a current events consequences of that. So with that, I have reached the end of the sets of PowerPoints. I can open the chat room up and remind you that you can download both the PowerPoints and the worksheets from the 7th grade Giant site, which looks something like that. The problem is we just finished repopulating unit 5 of that, and it's going to have 8 units by the time we're done. If you want to see the clickable maps that I have used frequently in here, including a clickable map about empires and some clickable maps about China, that's up on the Wexford Misaki Independent School District site. And you can explore those. And there are a number of other people, including a couple of people sitting in on this session right now, that are doing sessions about using clickable maps to tell stories. So I chose not to do that. I chose to focus my story primarily on that one graph of climate change and that one basic principle. And I hope I have copied that, but I didn't leave it on the end here. So we're just going to leave it about right there. If you've got questions, you can go to the chat room. We got 10 more minutes, I think, or something like that. Maybe not. We don't have anybody kicking us out, so. Or you could spend the time going out and actually looking at the horse's mouth, which is the stuff that's up on those 2 websites. So maybe I should find my way back over to them. Oh, somebody asked about the resource about the steppe people. The book resource is written by a guy named David Anthony, and it's called The Horse, the Wheel, and Language. The problem with the book is that you have to have a real bad case of COVID insomnia because the prose style is a little bit on the stodgy side. On the other hand, he has made several TED Talks, and if you enter him into YouTube, you will get the TED Talk version of it, which is the short and quick version of it. And the genetics, I would not trust that source. I would just put in the words Indo-European DNA and do a Google search right now and find what you get. And again, YouTube has got a half dozen versions of the Indo-European story. I can't recommend one over the other because I've tended to watch those kinds of things about 10:30 at night. My cylinders aren't all operating at full tilt at that time. Well, I think somewhere around here I'm supposed to have a closed meeting button, but I have no clue where it is. If I stop share, there we go. We got end at the bottom. And I don't know if that ends me or the whole meeting.
Well, if you click on that, you'll get an option that says end meeting for all.
Oh, there we go. But see, Uncle Davy is here to rescue me because my tech chops are skimpier. So, end meeting for all of for everybody who hasn't bailed out already. I don't know. Let me go see how many participants we have.